All right, we're moving on to section 9.5, special right triangles. You can make an argument that this section, along with the upcoming trig sections, are the most important sections in the entire curriculum this year. It's because you'll be doing a lot with this next year and the years that follow. So make sure you pay attention and make sure you get your questions answered as we go through this section. Okay, so let's jump right in and let's talk about 30, 60, 90 and 45, 45, 90 triangles. So if I have a right triangle and one of the angles is 30, which makes the other one 60 degrees, then the side that's opposite of the 30, we'll call that x. The side that's opposite of the 60 is related to that x in this way. It is x and then multiplied by the square root of 3. And the side that's the hypotenuse, the side opposite the right angle, is also related to the x in that it's just double the x, so 2 times x. So again, just to summarize, the side opposite the 30 is x, the side opposite the 60 is x root 3, and the side opposite of the 90 degree angle, or the hypotenuse, is 2x. So it's always going to be x, x root 3, 2x. For a 45, 45, 90 triangle, that means it's an isosceles right triangle, 45, 45, 90. Both of these sides will be called x. Obviously, they're going to be the same. This side, I mean, I could basically do x squared plus x squared equals y squared and solve for y. But this side is going to be x times the square root of 2, always. Okay, so if we're looking at 45, 45, 90, it's going to be x, x, x times the square root of 2. All right, so let's try some problems down at the bottom, and you'll see that this will come in handy big time. So if I look at this first one here, actually this first row, the side opposite the 30 is already given. But now, because I know the side opposite the 30, I can find the other two sides right away. The side opposite the 60 is going to be 4 root 3. And of course, the side opposite the 90, the hypotenuse, is going to be 2 times the x value, or it's going to be 8. This one, it's giving you that the hypotenuse is 12, so this is the 2x side. So you always want to try to find the x first if you can. The side opposite the 30 is the x. It's just going to be half of the 12, so it's going to be 6. And that means that this will be 6 times the square root of 3, because that's the side that's opposite of the 60 degree angle. So the next one, this is 30, and now, this is a little trickier. The side opposite the right angle, the hypotenuse, is going to be 18 root 3, so now I can find the x is going to be half of that, right? So it's going to be 9 root 3, and so now this one is going to be 9 root 3, that's my x value, times the square root of 3, because the side opposite the 60 is x times the square root of 3. Root 3 times root 3, we know it's just 3, so this side is going to be 27. All right, this is where it gets a little bit trickier. The side opposite the 60 is now 12. Now keep in mind that 12 is the x times the square root of 3 side. Now I can solve for x here, knowing that equation, given that equation. So x is equal to 12 divided by the square root of 3. Rationalize the denominator. So I'm going to get 12 root 3 over 3, or 4 root 3 is my x. That's going to be the side that's opposite of the 30 degree angle. And now the hypotenuse, we know, is just double that, so it's just going to be 8 times the square root of 3. Okay, so let's try some 45, 45, 90 triangle problems. So if this is 9, we know this has got to be 9. It's 45 degrees. The isosceles right triangle. And this side is going to be just simply 9 root 2. In this case, it's given that this side is 7 root 2, so I know that this is just 7 and 7, since this is x times the square root of 2, and these are my x's. And now this side is 14, so 14 is equal to x root 2. Solve for x is equal to 14 divided by root 2, or it's going to be 2 root 2, 7 root 2. So these will each be 7 root 2. Alright, let's try some problems on the backside. Okay, we're moving on to the backside here to try some application for the 30, 60, 90 and 45, 45, 90. Let's take a look at problem number 3 first. Find the perimeter of PGR. And so I have a 30, 60, 90 triangle. I have a couple of them actually. I have the smaller one and I have the big one. And I'm given this side is 15. So that's the side that's opposite of the 60 degree angle. So that means that 15 is equal to my x root 3 side. So x is equal to 15 over root 3, which means that x is equal to 5 root 3. So that's going to be this portion right here. That's 5 root 3, which makes this bottom 10 root 3. Now, if I focus on, well, I can see that this is 60 here. If 60 degree side is 5 root 3, then I know that this side here has to be 5, and this side here has to be 10. And then I just add those 3 sides up and I get the perimeter. It's going to be 15 plus 5 root 3, and just leave it like that. Okay, next one. Find the span of a regular hexagon with the perimeter of 54. So if the perimeter is 54, then I know each of the sides is going to be 9. And these are all, as we know, equilateral triangles. And if I draw an altitude here, I know that this is also 9. And this is going to be 4.5. It's half of 9. Which makes this, because this is a 60 degree angle right here, it makes this side right here 4.5, sorry about that, 4.5 root 3, and if I double that, that's going to be the span over here, and so 4.5 root 3, double it, you get 9 root 3 as my span. Okay, regular octagon with a perimeter of 48. That means that each of the sides is going to be 6. These are all 6. And if I kind of draw this out like here, can you see you're going to end up with a whole bunch of 45, 45, 90 triangles right here? The other way of thinking about it is we know that for an octagon this angle is 135, so this has to be 45. And if this side is 6, that makes this side 3 root 2. And we're looking for the span, which is from here all the way to here. So now I know that this is 3 root 2 right here. And so the span is going to be the same as this length of this entire side right there. So it's going to be 6 root 2 plus 6, and that'll be my span. Okay, this last problem down here I know is missing some information. It's missing the length of AC, which is going to be 6. And so this is 30, this is 15, which makes this 135. And this one has a little trick. It's a little tricky because you have to draw in a triangle right here. And that's going to be a 45, 45, 90 right triangle with a hypotenuse of 6 right there. So that means that, I think from the previous one of the previous problems, this was 3 root 2. This is 3 root 2. And hopefully you can see that if I focus on the big right triangle, that triangle is a 30, 60, 90 right triangle. And so if this side is 3 root 2, then this side has to be 6 root 2. Because that's the side opposite, that's the hypotenuse side. And this is my x. And the entire bottom is my x root 3 side, so it's going to be 3 root 2 times root 3, or 3 root 6. And then what am I supposed to look for here? I'm looking for the perimeter of ABC, so I need that piece right there. That piece right there, I know this and I know this, so it's going to be 3 root 6, the entire length, minus 3 root 2, which is the dotted red length. And now I can just add all these up. So I have this, this, and this. Add them all up, and I will get, I believe, 3 root 6 plus 3 root 2 plus 6. That's my perimeter of triangle ABC. Okay, I'm going to stop here and let you try some problems on your own. Okay, good luck.